Our last speaker of the morning session is Keith. I probably brutalize your name, Besserud. And Keith is actually the director of the Black Box group at SOM in Chicago that some of you might know. They've done a lot of digital computational environmental performance work. Keith is a graduate from the University of Illinois Urbana-Champaign as well as from Georgia Tech, and he recently also got a degree at the Stevenson's Institute that also has done some really interesting work on design computation and combining design and technology. Keith, actually the history where we tracked down Keith was that he wrote a really interesting paper on SOM's work on digital performance evaluation at the urban level, and in a way lamented the lack of existence of a tool. So we really wanted to engage in a dialogue with you today. So thank you for coming.
Thank you. So yeah, one of the things that I feel like I'm picking up on here today is, and something that we've been thinking about a good bit is where we are in terms of evolution as an industry and the use of these computational tools, and what it seems to me is we're sort of at this position now where we're moving from talking about, hopefully talking about, individual modes of analysis to more integrated modes of analysis, and that's kind of a general theme, I guess, in my talk here. So we have projects. So here's same project Cliff showed a little bit earlier. This was our take on it for the K-Care competition. But these are enormously complex propositions here, and we've got a number of things that have been evolving in terms of the development of tools commercially, as well as firms that have the capability to develop in-house tools to try to attack these things. But we're still very much, I think, at a point, for the most part, where trying to understand these things in an integrated way, I think, is still a difficult thing. So we have, as I said, a number of modes of examining specific issues on different projects. The radiation, CFD in terms of wind flow analysis through cities. Although I want to make a footnote on this particular issue. This is something that as the architecture practice in our office, we're vitally interested in as well, because we do a lot of tall towers, and wind is a huge issue in terms of structural forces and the design of structural systems on buildings. So we've been taking a real hard look at CFD packages to see if we can use them to help us with early stages of design. And I have to say we've been unable to get comfortable with correlations between CFD analysis and wind tunnel analysis, to the point that we're in the process of developing our own wind tunnel in-house so that we can get a better handle on these things. So whenever I see CFD analyses, and we do them all the time in our practice, I'm a little bit skeptical about taking those results to heart. And that goes to a larger theme, I think, which is just validation in general of all of these computational tools. I think it's something I feel like we don't see enough of in terms of understanding the efficacy of these tools. Distance analysis, getting into GIS tools, view analysis, from an urban perspective, the impact on economic considerations in terms of what developers can sell or lease their developed space for, based on ability to see things. So all of these things are sort of isolated components, of analysis, and what I wanted to talk about mostly this morning was efforts, initiatives that we're undertaking to try to get a more integrated understanding of the relationships between these different silos of analysis on each other. So I mean, compared to Arup, I have to say we're a little late to the party in terms of thinking this way, probably, but we're at the party now, and hopefully we'll have something to contribute to the party before too long. So same, very similar sort of idea, trying to take a holistic look at the elements, the components of an urban design proposition, and to begin thinking very clearly about what are the metrics that are associated with those with each of those individual categories, and defining metrics, and more importantly, in terms in which we can actually measure them. Is not a simple thing. In architecture, we're a little bit further down the road in terms of defining standards of comparison and standards of metrics. On the urban side, there's some catching up to do, I get the sense. And let me preface that by saying I'm not an urban designer. I'm an architect. I've been interfacing a great deal with our urban design group in the last couple of years, but I have to be careful that I don't mischaracterize something about what's going on there. So the idea of the interface for the designers, of being able to get feedback in their hands very quickly. We're still in a process of prototyping different ideas about how that might work. And then from there, looking at just sort of the idea of having base models that are able to leverage intelligence in a much more effective way. So again, looking to architecture and what's emerged in terms of BIM in the last several years, and asking the question, where is BIM for urban design? Object-oriented urban objects in a model that can contain intelligence. So we have all of these beautiful 3D Studio Max models and so forth that are very effective in terms of visually communicating the physical nature of a city. But you'd really love to be able to click on every one of those buildings and drill down and get a whole bunch of information, not just about the building, but its relationship to its urban context. Understanding that these are all connected to each other in some way. In multiple ways. And so here we're experimenting with an idea to develop a database that would allow us to, in 3D Max or in Rhino or in AutoCAD or whatever, to develop building geometries, to click on them and tag them with a use type, and then in the background have all of this data about that use type that immediately gets added to the model. So its energy consumption profile, its water consumption profile, based on its use type, and then to be able at the urban scale to define a polygon that might describe a district or a region, and then get the model to sum up all that information so we can understand something about water balances or energy peaks and that sort of thing. And as I said, to be able to click on the pieces of the model and instantly get information feedback. So this ability for designers to be able to access information in a much more effective way that's integrated into the design process more effectively. So along those lines, a project that's very active in the office right now is called Lakeside, which is located on the south side of Chicago. Up at the very top is the downtown Chicago core. It's about 11 miles south of the downtown core. The site currently, where all these taller buildings are in the foreground here, is vacant. It used to be a U.S. steel mill that was torn down, and the site was remediated. And there's a number of things that are really interesting about this project, but one of the things that's pertinent to this discussion this morning is the fact that there are no utilities on the site. So most of the projects, I guess, sort of the K-care notwithstanding, kind of, most of our work is in urban developed areas already. It's not new cities. And in those cases, obviously, there's infrastructure that already exists. And usually, the different components of the infrastructure system are all delivered by different agencies. And they're not coordinated. They have their own business agendas, and they pursue them for their own sort of optimal purposes. In this case, what's being discussed is the idea of the development of a neighborhood utility. So because of the fact that there's no infrastructure on site already, we can talk about the possibility of having a neighborhood, some sort of quasi-governmental agency developed that could take control of the electricity, the water issues, ICT, wastewater, a number of the things, and bundle them together and see if we can develop some synergies by having the ability to fairly easily capture the waste heat, for example, that's coming off of the electricity generation system and leverage it, as has been discussed many points here this morning already, in terms of district heating and district cooling. So, this is not typical for us, I would say, to date, to be getting into this next level of specificity, this higher level of development with respect to the infrastructure systems. This isn't something we've typically been doing, but because of this nature of this opportunity, we are. So, actually beginning to think about how this stuff gets distributed, what's the components of the different pieces that go together. So, there's all kinds of alternatives in terms of generating electricity or cleaning wastewater. What's the right mix of all of those different technologies that will allow this to actually become economically feasible? When you start trying to wire all of those connections together from the different systems in a manual way, it becomes pretty complex pretty quickly. And then to layer on top of that the financial considerations, the fact that this neighborhood utility will collect income from the residents. They will have a cost to generate the different utilities that will be provided to the people that live in the community. Is there room to make money off of such a proposition? And it has to make economic sense, because we're talking about a private developer here, not a public agency of some sort. So trying to understand that economic argument is a really, really difficult thing. So we're in the process of developing a modeling framework to help us get a better handle on this. So we have one. It's called Excel. It's not the most user-friendly kind of environment, right? So we're trying to look at this from a more sophisticated perspective, and maybe even get into some agent-based modeling to try to understand the dynamics of this thing as it cycles through time. And the sort of basic framework that we're looking at the moment is an idea of a database using the CityGM. Our German friends, I'm sure, are very well aware of this standard as a common standard for developing this database that would describe the the syntax of the city. Developing translation mechanisms that would allow us to then layer on a number of different analytical components that would all communicate with this system, and then on top of that, an algorithmic layer which would help wire everything together, and then eventually even move it into some idea of optimization. So one of the questions is, where are the commercial developers in all of this? Arup obviously, has a history now, very strong reputation for developing these kinds of tools. SOM is doing some of that. Where are the commercial players? And from my perspective, even coming from the leader of a computational group, I would much rather have a commercial developer out there providing these tools that we can just buy a license for, that they support, rather than us, having to develop everything from the ground up in a lot of these cases. What I'd rather have is them providing those tools with a great API so that we can get in there and sort of customize what we want to do rather than building the whole thing. So we've been working fairly closely with ESRI of late to look at this City Engine platform that they've recently acquired, to turn it from what was a platform for supporting film and computer gaming to a platform that could support urban design and urban operational management, let's call it. So this idea that we've been developing with developing a plugin for 3D Max and the database and so forth, we're kind of moving that towards the shelf and adjusting our focus on how can we make this turn into something that would be of great use to us. So hopefully we'll be seeing more from the commercial companies stepping up with these kinds of tools as well, or maybe they'll make somebody at MIT rich by buying them out and taking their technology and developing that into something that's widely available. So moving from analysis then, now I got two more examples here into sort of more generative kind of ideas. This is something that we developed a few years ago, actually, as one of the black box people, after he had done this, shortly after came to MIT and got his degree in the design computation group, Josh Ingram. I don't know if anybody knows Josh. But he did this actually before then. And so this was looking at what happens if we try to understand buildings as agents and embed them with knowledge and rules and relationships that somehow mimic the reality of what happens in the way that cities grow. And the whole thing is based on an idea of measuring happiness. So this was obviously a very sort of fundamental research kind of idea. The notion wasn't that we were going to be applying this in any time soon, but what we were trying to measure was building happiness, and to do that we had a series of rules that related to each building understand what was going on in its immediate vicinity. So we had 5 different building types, and each building type had a specified ideal mix of other buildings that it wanted to see around it. So if I'm a type A building, which might be a residential, a commercial, retail, whatever, sort of laws of real estate economics are such that I want a certain amount of type B and type C and type D and E around me. If I'm a type B building, I have a different mix that I want around me ideally, and so on for the other types. And so if two buildings end up, show up next to each other that have very different mixes, that sets up sort of a competition, because somebody's going to be happy and somebody's going to be unhappy. And in this system, if you're happy, you grow. If you're unhappy, the opposite of grow. And if you're unhappy long enough, you die, basically, and the parcel gets freed up. So at each, it's an iterative idea. At each iteration, one new building is pushed into the system. There's a probability routine that determines what type of building you'll be and where you'll be located. And then once you land on the site, you immediately assess what's going on around you. And if you like it, you start growing. If you don't like it so much, you don't grow. And I've got a time-lapse animation here. And what you'll see is that buildings will show up, and if you watch some of them, and along the fringes, there's not enough around there to keep them happy, and they'll disappear fairly quickly. But once they kind of like what's going on around them, then they'll take hold and they'll start growing. And there are rules in here also that related to allocation of green space and what happens to your happiness if you're adjacent to the green space. There is a rule that dealt with your age that said up into a certain number of iterations, age doesn't affect your happiness, but once you hit a threshold, you're not so happy anymore, and then you start, decreasing. Like I said, this was really just a sort of thought experiment in a way. I mean, the rules are somewhat superficial, but the system was built with the idea that we could get the real rules at some point, talking to economists and real estate professionals and sociologists and psychologists and so forth, and actually replace the placeholder rules with more, sensitive rules. And so anyway, that was this experiment. So and obviously you could take sustainability rules, right? Same way to address a building's happiness and have that become part of the system as well. And then one last thing then. So all of this. So in the last couple of years, I've become involved, helped co-found actually a group called the Urban Systems Collaborative, which consists of, the founding groups were SOM, IBM, Cisco, Esri, NYU, American Planning Association. There's quite a few of them actually, and the idea was to try to bring together a very diverse group of people, a diverse group of interests that were all had a common thread of sort of interested in urban, the urban condition basically, and to some extent growing out of I think IBM was probably the biggest cheerleader of this thing, but growing out of the smarter cities kind of mentality, and trying to understand what that might really mean, and what that has come to mean for me is basically the question of the significance of information flows on the dynamics and the behavior of cities. So, there's been some interest, and at MIT in particular, I know of the idea of urban metabolism, of thinking about cities as biological organisms in some way, and the metabolism in terms of processing of energy and of matter primarily. And taking a look at the world of biology, I think what's maybe missing from there is the processing of information. And so when you look at what's happened in the world of biology in the last several decades, going back to the 1950s, when Crick and Watson sort of uncovered the structure of DNA, and then shortly thereafter laid out this very, very important fundamental idea that all biological systems stem from this flow of information that goes from DNA to messenger RNA to proteins, and then from proteins to distribute all kinds of signaling throughout a biological system. And so the field of biology, this is sort of a watershed moment that marks the point at which biology became the study of information flows, as opposed to what had previously been primarily the flows of matter and energy. And so now where we are and so, obviously from a stem cell, the ability within that agent to differentiate itself as it develops into any number of different types of cells throughout the whole body. And the fact that every single one of those cells contains an entire copy of that DNA instruction set. And then after development matures through the ongoing operation and, continuing, keeping people and any kind of biological system alive, all the instructions that are required to do that are essentially a flow of information signals. And in biology, they're at a point now, this is called a metabolic pathway, which is an attempt, a very complicated flow chart that basically describes all of the metabolic exchanges of information throughout a biological system. And not only that, but understanding systems in terms of their information nature has even transformed biology's understanding of the tree of life and thinking about it now from a genetic perspective as opposed to just a sort of a formal perspective. And I mean, news comes out every day about research linking the potential for medical treatments to the nature of the information that exists in biological systems. And the ability now to talk about very targeted interventions that instead of just sort of obliterating a whole system are able to go very specifically at key targets within a biological system to administer treatment. So plenty has been made about analogies between biological and urban systems. The question is, how deep is that analogy? And when you look at urban systems and biological systems, what might that mean in terms of information flows? And the fundamental question I guess I have is if we were able to think about urban systems, if we were able to conceive an information-centric theory of cities, could that open up the possibility of revolutionary treatments, i.e. urban design and policy making with respect to the urban condition in the same way that has happened now in biology. All of these, this genetic engineering, these stem cell research, these targeted treatments, none of that happens without this fundamental understanding of biological systems as information processing systems. And what happens if we had that ability to look at cities that way? So what is the urban equivalent of DNA and genes and cells and so forth? What's the urban equivalent of that metabolic pathway diagram? What are urban species? And what can we understand better about cities when we understand their speciation? And what's the equivalent of genetic engineering and targeted treatments in the urban context? And then flipping it on the biological side, what's the equivalent of people in neighborhoods and economic systems and so forth? What's the biological equivalent of an instant city for 1 million people? What's the equivalent of urban renewal? So I'm basically leaving with some questions, and along this front. So we've engaged with some folks, some research scientists at Argonne National Lab outside of Chicago, to start probing this a little bit and taking a look at the models that the biologists already have command of for understanding these extremely complex systems, and try to begin to understand, is there something we can take away from that to apply to the urban domain? And that's it. Thank you.
Excellent presentation. We have some time for questions.
Okay. You mentioned at the beginning your interest in commercial software with good APIs. What role do you see open source softwares having for sustainability? And if you use it and write extensions to it with an API, what responsibility, if any, do you have to give that back to the community?
Yeah, that's a good question. We're involved a lot with the open data movement. that's coming out of a lot of cities right now as well. And on the data side, I have to say that I can't help but feel that there's tremendous economic pressures to monetize that data if it's available. And I'm, you know, and I just think that's, you know, in a capitalist market system, that's probably going to always be the case. As far as open software, we're using it some. I mean, obviously, you know, with the you know, the CityGML thing, we're going there in terms of, you know, an open standard. And I think maybe the open standard is sort of the part that we're more interested in, rather than, you know, sort of the open software itself. The tools that we're developing, actually the tools that like the view analysis tool that we developed internally in Black Box. We have a hard time even getting the other offices of SOM to buy into wanting to use it. In terms of software development, I think there's a certain culture where, to a certain extent, people that like to code their own software. They like to understand what's in there, and getting uptake of that. I mean, even across our own firm, I think has been somewhat slow. We haven't institutionalized it, I don't think, to the extent that I think Arab has. We haven't formalized it that way. So maybe the informality of it, is impeding that. But I don't know, the open part of it, I'm not sure, to be honest, in terms of what we feel like. If we had something to contribute, maybe we'd have put more thought into it. But I don't feel like we're to that point.
I think your answer to that is correct, and certainly the idea that even when you have these systems, everybody wants to invent their own. Engineers are especially like that. And if I think how long it has taken to move from all of us playing with framework analysis, structural analysis programs in the 60s, to actually getting to a point where we just pluck them off and use them and don't care whether somebody else is or not. And those are strictly mathematical, cold-blooded things. Right. And now and then just move forward, and the same applies to CFD, and move forward to CAD and for instance Revit MEP, and just look at the agonies we're still going through to really say that that's good. This stuff is far more still full of flavor, and I think it's a while before it will standardize and settle down.
Yeah.
Any comments?
For the Lakeview project, you guys are having a stake in understanding the role of infrastructure planning and urban design, or rather the role of urban design and infrastructure planning, or how do those two interface for you? Do you have personal involvement in the project, and are there any links between what you guys do on the drawing board in terms of buildings and street layouts versus what's going on underneath the streets?
Yeah. So again, kind of late to the party. The infrastructure integration tool that I'm describing, again, we're collaborating with Argonne on this, and these sort of research projects don't track on the same timeline that the project development stuff does. So hence, we have this very painful, as I said, Excel spreadsheet that we're trying to use to understand these feasibility issues. So I would say that we're not to the point yet where we can iterate based on the data that's coming out of the model. The expectation is that we will be able to. But in an environment at SOM where there's not a formal research structure in place. There's not a line item in the annual budget that says we can spend this much on research each year. By and large, research is still obligated to happen within the constraints of a given project that's actually earning money. So the philosophy that we take is we define a research agenda and we move it along incrementally, one project to the next, until it's matured enough that we can actually deploy it on a project. And that's very much the case with this one.
City happy modeling scenario,
yeah.
Are you finding that there's distributions of mixed use or percentages of open space that keep coming up in patterns as you run this? Are you seeing patterns emerge from the running of this model?
You know, unfortunately, we haven't been able to sort of analyze what we're looking at yet. And this is a project that also is kind of on the shelf. That one and a number of things, you know, happened before the recession hit, when actually we were, you know, everybody was happy and nobody was paying a whole lot of attention. And then when the recession hit, you know, that sort of turned that faucet off, frankly. And so the basic research has sort of been shelved for, you know, further development. But I think this is something that we'd be interested in coming back to. And it's one of the things that, as we're developing this relationship with Argonne, and with their expertise in agent-based modeling and frankly, their computational capabilities, to bring this, I think that would be more the environment that we would bring this out in again. But I think that project just raises a whole lot of interesting questions. And I mean, it's like any research project, right? I mean, you hopefully answer your research question, but then you uncover all these other great research questions you want to then go after next, right? And that's definitely the case here.
So just in order to cut on everybody's time, it's too short, let's thank